Okay, so today we're in the final section of 10.3 and we're looking at solving nth roots. So nth roots are basically everything that we haven't done so far, meaning the stuff that isn't square roots. And taking a look at nth roots, we're just going to look at a few problems and you'll see how it's similar and different to what we've already done. We're going to begin with the cube root of 5x minus 2 is equal to 12. And this problem is quite similar to solving any of the square roots that we've worked with in the past, because what we need to do here is we need to undo the third root or the cube root by taking it to the third power. So we're going to take both sides to the third power. Now I'm going to go ahead and use a calculator off screen to figure out what 12 to the third power is, because I legitimately have no idea. 12 to the third power is 1,728. And the cube root of 5x minus 2 cubed is just going to be 5x minus 2. So from here, we need to solve for x like we would in any other problem. We add 2 to both sides. That gives us, let's see, 5x is equal to 1,730. And I don't know what 1,730 divided by 5 is, because that's going to have to be our last step. To get our x alone is to divide both sides by 5. And that gives us an x equals 346. Okay, well, you're probably looking at this and saying, wow, that was super easy. No problems there. And let's go ahead and take a look at another problem and see what happens. So our next problem is going to be the cube root of 3c minus 7 is equal to negative 10. So once again on this problem, we are beginning in exactly the same place we did on the last one. We need to take the cube root of both sides, or we need to cube both sides in order to get rid of our cube root, excuse me. So when I cube the cube root of 3c minus 7, it just becomes 3c minus 7. And when I cube negative 10, this is going to end up giving me negative 1,000. One thing to note is that because we're using an odd number power here, the negative number on this side remains negative. And you won't find occasions where you'll need to check your work to make sure that you got a legitimate answer, because it is actually possible to get a negative value outside of a cube root, because as we just saw, the cube root of negative 1,000 would be the negative 10 that we cubed up here. Anyway, we then need to add 7 to both sides, and that will give us 3c is equal to negative 993. And after dividing both sides by that 3, we are finally left with c is equal to negative 331. And if you needed to prove it to yourself, you could go through and find that 3 times negative 331 minus 7 does in fact give us negative 1,000, which is equal, the cube root of negative 1,000 is negative 10. All right, we're going to do another example, this time with an even larger root value. So in this third one, we're going to have the fifth root of 8x minus 15 is equal to 1. And we need to solve for the fifth root of this. And just like the previous problems that we worked on, this is going to proceed exactly the same way. We need to take both sides to the fifth power to undo our fifth root. Now, obviously, 8x minus this fifth root of 8x minus 15 to the fifth power is just 8x minus 15. But we need to figure out what 1 to the fifth power is. 1 to the fifth power is 1 multiplied by itself 5 times, which is just 1. From here, it's a two-step problem. We need to add 15 both sides, giving us 8x equals 16. And then divide by 8. We get x is equal to 2. All right, well, that proceeded in just the same way as the other ones, basically identical problems. We just ended up needing to take something to the fifth power instead of the third power. So picking the power you need to take something to is pretty easy, because you just need to look at the index of the radical and then take it to that power and take both sides to that power. Now we have one more question, which is going to be a little bit different. And this one, we're looking at the fourth root of x minus 2 minus 2 is equal to 0. So this minus 2 is sitting here on the outside. So before we can take the fourth root of this, or before we can take this fourth root to the fourth power to undo this, we need to add 2 to both sides. This gives us the fourth root of x minus 2 is equal to 2. From here, we then need to take both sides to the fourth power. The fourth root of x minus 2 to the fourth power is just x minus 2, and 2 to the fourth power would then be 16. Add 2 to both sides, and we get x is equal to 18. So if the index, which we saw here, was 5, and this problem was 4, and the previous two it was 3, you just take both sides to the index power and then solve for x as normal. And hopefully, unlike in those first two problems, they'll be a little bit nicer and the numbers won't get totally out of control for you. All right, well, that covers taking a look at various nth roots, meaning roots that are bigger than 2 primarily. For the most part, you only have to deal with roots that are 3, which is what we see here and in these two problems. But it's pretty much the same set of solutions. You do still potentially need to check to make sure that you don't have extraneous solutions on the even power nth roots. For example, this one didn't end up being a problem because 18 minus 2 is just 16. But if this had instead been plus 2 over here, and we had instead ended up asking what the fourth root of x minus 2 equals negative 2 is, this would have ended up yielding an extraneous solution because we would have ended up going through it all again. We would have ended up with x equals 18, but the problem then would have been that 18 minus 2, the fourth root of 18 minus 2 is positive 2 rather than negative 2. So when our index is positive, you do need to potentially watch out for extraneous powers, just like you would with regular square roots. If it's odd, we don't even need to think about that. But overall, it should be pretty consistent with what you learned in the first two videos.